Okay, hi everyone, welcome back to this video series on the Cisco ASA firewall. IP version 6. IP version 6 is a relatively new IP protocol developed to fix the shortcomings of the current IPv4 implementations. When IPv4 was standardized in 1981, the current challenges were not anticipated. The challenges include exponential growth of internet usage, scalability of large routing tables on the internet backbone routers, supportability of real-time data delivery. IPv6 not only fixes these problems but also provides improvements to IPv4 in areas such as IP security, network auto-configuration. With the increased use of IP-enabled wireless phones and PDAs, the IPv4 address space is running out. Although network techniques such as network address translation and short-term DHCP leases have helped to conserve these addresses, more and more home users are demanding always-on internet connections. To accommodate the growing global demand for IP addresses, the new IPv6 implementation quadruples the number of bits used in an IPv4 address from 32 bits to 128 bits. It provides 2128 routable IP addresses, enough to assign over 1,000 IP addresses per person on this planet. IPv6 header. IPv6 specifications defined in RFC 2460 describe an IPv6 header as shown in figure 3.4. In the case of IPv4, an IP address is represented in 4 octets separated by dots. To accommodate a 128-bit IPv6 address, the address is divided into 8 blocks of 16 bits, each separated by colons. Consequently, this representation is referred to as a colon hexadecimal notation. The following are a few examples of IPv6 addresses. So as you can see here, so I'll just run through this. FEDC colon BA98 colon 0001 colon 3210 colon FEDC colon BA98 colon 0001 colon 3210 1080 sorry 10800000 colon 0000 colon 0000 colon 0008 colon 0800 colon 200C colon 417A, all the zeros there, colon and 0001. So IPv6 header fields, field description version, a 4-bit internet protocol version number equals 6, traffic class, an 8-bit field that enables the source to specify a desired delivered priority of its packets relative to other packets, a flow label, a 20-bit field that may be set to request special handling of packets by the IPv6 based router, payload length, a 16-bit integer that specifies the length of the data payload, next header, an 8-bit field that identifies the type of header field following the IPv6 header, hop limit, an 8-bit integer that is decremented by 1 whenever the packet passes through a network node, source address, a 128-bit address to identify the packet source, destination address, a 128-bit address to identify a packet's destination address. In IPv6 addresses, in an IPv6 address, it is not required to write the leading zeros in an individual block, as in IPv4. Thus, the preceding addresses can be written as follows. So here's the full IPv6 address, and that can be broken down using the colons, as you can see here. As you can see from the preceding address, an IPv6 address may have long strings of 0 bits. For ease of representation, an IPv6 address with long sequence of zeros can be compressed and replaced with a double colon or triple there. This notation, also known as a double colon, can compress contiguous blocks of zeros. However, the double colon notation can appear only once in an address. To avoid confusion on how many zeros to go with the instance of double colon, the preceding address with zero compression can be written as FEDC colon BA 98 colon 1 colon 3210 colon FEDC colon BA 98 colon 1 colon 3210 1080 double colon 8 colon 800 colon 200C colon 417A double colon 1. Configuring IPv6. The security appliance supports a number of IPv6 features, which include IP address assignment, packet filtering, basic routing using static routes, neighbor discovery, limited remote access VPNs, and IPv6 supported applications such as FTP, HTTP, and SMTP. This section discusses IP address assignment, whereas packet filtering and basic routing using static routes are discussed in Chapter 4 and Chapter 5, respectively. In version 8.2.1 or higher, the security appliance supports the intrusion prevention system, IPS, and transparent firewall features. IP address assignment. The security appliance supports simultaneous IPv4 and IPv6 addresses on an interface. You can configure an IPv6 address on an interface by navigating to Configuration, Device Setup, Interfaces. Select an interface, click the Edit button, and then select the IPv6 tab. As shown in Figure 3.15, the security appliance supports 4 types of interface address assignments: global unicast address, site local address, link local address, auto configuration address. So global, so here you can see here in Figure 3.15, IPv6 address assignment, global unicast address. A global unicast IPv6 address, similar to an IPv4 public routable address, is used for internet connectivity. It uses a prefix of 2000 double colon /3 and requires a 64-bit interface identifier. In the extended universal identifier 64 EUI64 format, each physical interface has an embedded 48-bit MAC address that specifies a unique linked layer address. You can derive the EUI64 format interface ID from the interface MAC address by using the following rules. Insert FE between the upper and lower 24 bits. For example, if the interface's MAC address is 000.f775.4b57, the modified address will be 000f.f74ff.fe75.4b57. Change the 7th bit in the leftmost byte to 1. For example, if the 64-bit address is 000f.f7ff.fe75.4 B57 derived in the previous step. After the 7th bit is changed, the new address becomes 020f.f2ff.fe75.4b57. The new address is in the EUI64 format. Site local address. A site local IPv6 address similar to an IPv4 private address is used for the hosts on the trusted networks that do not require internet connectivity. It uses a prefix range of FEC0:10 and it uses the EUI64 format interface ID for a complete IPv6 address. The use of site local addresses is deprecated by RFC 3879. Therefore, the configuration of a private IPv6 address should be done based on the recommendations of unique local addressing in RFC 4193. Link local address. A link local IPv6 address allows IPv6 enabled hosts to communicate with each other by using the neighbor discovery protocol without needing to configure a global or site local address. The neighbor discovery protocol provides a messaging channel on which the neighbor IPv6 devices can interact. It uses a prefix of FE80:10 and an EUI64 format interface ID as the complete link local address. The link local address is auto-assigned to an interface when IPv6 is enabled. To manually assign a different link local address, configure an IPv6 address in the link local address option as shown in figure 315, where an IPv6 address of FE80:20f:/F/Fe75:4b58 is being assigned. The security appliance enables you to assign a link local address on the interface if you select the Enable Address Auto Configuration option. The security appliance listens for the router assignment RA message to determine the prefix and generates an IPv6 address by using the EUI64 format interface ID. Example 315 shows a complete IPv6 interface configuration on the outside interface where a global address of 2001:1AE2:123F:/48 and a link local address of FE80:20F:/Fe75:4b58 are configured. So you can see here IPv6 addresses. Optional IPv6 parameters. The security appliance supports a number of IPv6 option parameters that are configured under the IPv6 tab on an interface, as shown earlier in figure 315. These parameters are discussed in the following sections. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.